Hello everyone, I hope you guys are doing well. Today we are going to discuss one more interesting interview question problem on JavaScript arrays. So without any further delay, let's get started. So what's the problem statement for today? So today's problem statement is to implement a array shuffle method. We all know what does shuffle do? Shuffle randomly shuffle the elements of an array, right? For an example, if we have been given an array with 3 elements, and with 3 elements we know there would be total 6 permutations. For an example, for 1 2 3 it would be 1 2 3 2 1 3 2 3 1 and so on, right? So our shuffle method should met two precondition. So first precondition is it should do the changes in the array as inline or in place to call it, which basically means we are not supposed to do or use any intermediary data structure or any temporary array to temporarily hold our values. We have to make the changes on the given array itself. So when we are shuffling the elements, we have to basically shuffle the elements on the given array itself. Second precondition is all element orders should have an equal probability. So if I'm shuffling the elements, it shouldn't be like this combination is getting returned or is getting as an output most often as compared to other. So there are equal chances that any of the possible permutation gets returned as a possible output, or basically that becomes the next shuffled version of the input array, right? I hope that makes sense. Now let's jump into the code. So as part of code setup, I have this index.html file and a simple plain JavaScript file, and here is our here is our shuffle method with empty implementation. And right now we have this input as 1 2 3, and this is before shuffle and this is after shuffle, and here we are calling the shuffle method on our input. And if I save this file, right now both look same, but when we implement our shuffle method, then this should our input element will be, our input array will be shuffled after line number 24. So now let's discuss how we can shuffle the element. So the very first approach is which we can implement is the using array.sort method. Array sort method. Let's see how we can use this sort method to shuffle the array elements. This is not the correct implementation, but we will start with this and then finally we will approach to the correct implementation. So let's see how we can do that. So array.sort, we all know sort takes two parameters, a and b, right? A and b. And to sort the numeric array, basically we return a number if a is less than b, right? So if a is less than b, then we return a negative number. If a is greater than b, then we return a positive number, and if a is equal to b, then we return 0 to basically sort our array with number elements. But here we want to shuffle the array elements randomly, right? So we are not actually concerned about what the value of a and b is. We have to randomly return this right hand side of the things, positive, negative or 0, right? So what I will do is math.random, and I will give a minus, whatever the output of this math.random, I will subtract 0.5 out of that, right? So if math.random gives 0.9 and if I minus 0.5 out of that, so it will give me 0.4, which is a positive value. If it gives if it gives 0.1, right, and if I minus 0.5 out of that, then my outcome of this function will be minus 0.4, which is a negative value. And if it's 0.5 only, then it would be 0. So that way my array elements will be shuffled randomly. Let's save it. And I saved it, array.sort math.random minus 0.5. And after saving and refreshing the screen, you can see the array elements is getting reshuffled. So our original input was 1 2 3, and next time we are getting 3 2 1. So there are chances that we will get the same order as well. You see, there are chances that I am getting 1 2 3 more often. So this implementation is failing on point number 2. So 1 or 2 are such combination which are getting more probability of getting returned as an output, or becoming the next random version of the array. And we can test this with a bit of code as well, and that code is here with me. So let me paste that here. Yes. Okay, so let's understand what it is doing. So we have a count dictionary where we have listed all the possible combinations of 1 2 3. For example, our 1 2 3 can be arranged as 1 2 3, 1 3 2, 2 1 3, 2 3 1, and all. And right now all are initialized to 0. That there are 0 iterations or 0 counters for each combination. And next we are having a loop up to this many times, and we are shuffling 1 2 3, and whatever the version comes after shuffle, we are incrementing that particular key only. And let's see after this loop how much each option gets as a counter, or how much each option gets a chance to be the next version of the output. And if I save that, yes, cool. Let's see. So 1 2 3, as we saw in our previous implementation, like here when we were comparing the output, we saw that this 1 2 3 was getting more often as the next version of the array, or next version of the shuffled array. So that is how we can see here as well. This is the most frequent, or the count is higher for this particular option. 1 3 2 is the least chances that 1 3 2 will become the next version of the shuffled array. And same here for other elements. So here the probability is the issue. So one of the possible option is getting higher probability of getting returned as the output of the shuffled array. So this is not gonna work. So if our condition would have been this only, that we should modify the array inline only, then this solution is fine. But because probability is a concern, we have to take care of the probability as well, then this solution not gonna work. So how do we fix it? So for this, the second method which is called is the Fisher-Yates algorithm. And what does this algorithm says? Let's understand using the other screen. Okay, what this algorithm say? For example, we have a given input as 1 2 3 4 and 5, right? What this algorithm says, start from the last element, right? So here it says start from the last element and pick a random number from the previous or the earlier set of available elements and shuffle it with the random element from that earlier list of elements. So what will happen after this iteration? So this is iteration number 1. So what will happen is, if I do this swapping, my final my list would be 1 2 4 5 and 3 is finalized now. Okay, so now I will move to the next element. So this algorithm says whatever is the element, you swap it with the earlier set of elements. So 5 I will replace with the random element. I will pick a random from here, say it gets replaced with 1, right? Now in my second iteration, this would become 5 2 4 and here 3 and becomes the final version here, right? In third iteration, my 4 will be replaced by the random element from the first two. Say it gets replaced with the 2, right? So here it will become, in the third iteration, it would become 5 and 4, 3 is final, 1 is final, and now 2 is final. So now 4 is the element, and we are left with only one element, so these will be replaced by with each other, and in the fourth iteration our final output will be 4, 5, 2, 1 and 3. So this is the shuffled array of elements, and in this algorithm each element is getting the equal probability of getting replaced with the next version of the element, and we will test it with our code as well, which we have written to. We will test it, our implementation, with this or code as well, and we will see that each possible outcome is getting a equal chance and is very closer to the other set of elements or other possible combinations. Okay, let's implement that for the Fisher-Yates algorithm. So what does it do? For I is equal to arr dot length minus 1, start from the last element until I is greater than 0 and I minus minus, right? Next is the temp location, and that we will find, for example, we can call it j only. Math.flow math.random into I plus 1, right? Here plus 1 should happen first and then multiply. So we got a random position before I, right? And then what I will do is arr of, I can use the array structuring operator, arr of I comma arr of j is equal to arr of j comma arr of I, and this also become the, so here I am using array destructuring. What I am doing is replacing I with j and j with I. So we are shuffling both the elements here, and for now let me comment this particular stuff, comment, or maybe just remove for now. First we just want to check if the array elements are getting shuffled, and this is our Fisher-Yates algorithm. I will leave a link to this particular algorithm for you to deep dive into this algorithm, right? And upon save, yes, so 1 2 3 is getting replaced with the 2 3 1. Let's do a refresh. 3 2 1 3 1 2 3 2 1 1 2 3 2 3 1. So here the elements are getting repeated less often, whereas in last approach the outcome was getting repeated, basically to be specific 1 2 3 was getting repeated more often. And now let's run a test here for the same possible set of combinations and doing the same loop, and let's see how much each possible outcome gets the number. Cool. Here you see, so here each possible outcome is very close to the other possible outcomes. For example, we can compare the first three numbers, 167 166 166 167 166 166, right? So here the probability is very close to the other possible outcomes. So that is how you can shuffle the elements for such type of problems where we can use the Fisher-Yates algorithm, where we have to take care of the equal probability as well. Otherwise the sort method can also help us in shuffling the array elements. Cool. So I hope today's problem was insightful. You learnt a new algorithm, right? And it helps build some understanding as well. And if that is the case, please do consider like, share and subscribe to our channel, right? And I am your friend Manish, and thanks for watching. Thank you. Bye bye. Take care.